Hello, this is Mr. Mashad, and I'll be talking you through a little video today on the Chapter 2 test review. I need a little dramatic music here. Let's see. That's better. Okay. First thing I want you to look at is the two pictures I have next to this paper, right here and right here. And I need you to have this memorized by Monday, although we've gone over this several times. We have basically everything that is real here, breaking the real numbers up into rationals and irrationals. And of course, rational numbers are any number that could be represented as a fraction. Now, more specifically than just being a fraction, you could be an integer. So that is also considered to be a real number. An integer is a real number. An integer is any number on the number line, such as 0, 1, 2, 3, and -1, -2, -3. So when I say we're adding integers, I'm talking about numbers like this. More specific than just an integer, whole numbers, that's your integers that are positive and 0. And last, the counting numbers, 1, 2, 3, 4, 5, also called your natural numbers. Counting like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, those are counting numbers. They do not include 0. So just some classifications here. Let's go to the questions. First question. We have -0.75. That was probably a fraction that was divided out to be a decimal. So that qualifies as a rational number. That would qualify as a real number, because everything in this is real. You should also look up here. This is helpful. So it's definitely a rational number and a real number, and that's the best you can do. You can't say it's an integer, you can't say it's whole and counting. And if you're love the music. If you are not an integer, then you can't be a whole number and you can't be counting. So once you cross out integer, you're automatically not whole and counting. Okay, so that takes care of number 1. We said it is rational. I'm going to abbreviate it as RIT, rational. And it is real. The most specific would be rational. The root 12. Root 12, if you take your calculator out and do 12 square root key or radical key, you're going to see that this is a real number, but it qualifies as irrational because irrational numbers have a decimal that goes on forever, and there's no pattern of repetition at all. So, your most favorite or most famous irrational number is pi. It goes on forever. There's no repetition at all. Now, if you go on forever as a decimal, such as 0.3333333, so on and so forth, you are rational, because you have a pattern. So patterns get stuck in the rational category, whereas going on forever with no pattern, you get put into the irrational category. So a slight differentiation there. Okay, so number 2 is irrational. It's real also. Everything we study in this class is going to be real. There is such a thing as an imaginary number. We will not study it. So everything is real to us. It's just, most specifically, it's irrational, number 2. Now 10 is rational. It's an integer. it's whole, and it's also counting. So you have to write all those down, somehow fitting all those answers into this little spot right there. So it's real, rational, integer, whole number, counting number. It's not irrational. So if you're rational, then you can't be irrational. Okay, the next one. The ones we talked about for the first time on Friday. It says, tell whether the statement is true or false. If it is false, give a counterexample. The first one, it says, if a number is positive, then its opposite is negative. So if a number is positive, then its opposite is negative. You have to know what opposite means. Opposite means that it is on the opposite side of the number line. So 3's opposite is on the opposite side, which would be negative 3. So be careful with that. It just means you're on the opposite side of the number line. Negative 1, its opposite would be positive 1. So if a number is positive, such as 3, then its opposite is negative. This is true. Number 5, if a number is an integer, then the number is an irrational number. Not true. And I need to bump this down to the right number. There we go. So number 5 is false. Give a counterexample. A counterexample would be something like, well, 5 is an integer, and 5 is rational, or 5 is not an irrational number. So you'd explain here as part of the answer to number 5. Number 6, 7, and that's it. 6 and 7, least to greatest. We have to remember that least to greatest means the bigger negatives are smallest in value, and as you work your way to a smaller negative, you get larger in value, up until you get to 0, and then once you hit 0, the bigger positive numbers are obviously larger. So just be careful with that. The larger the negative, the smaller you are. So the answer number 6 is negative 0.25, then negative 1/5, which we know negative 1/5 is the same thing as negative 0.2. And 0.2 is, it's closer to 0. So the smaller the negative, the bigger you are. 1/3 is the next largest, and then 1 is the largest. Number 7, same type of deal. The smallest for number 7 is going to be negative 14/3. Negative 14/3, if you think about it, 3 goes into 14 4 times, making 12. 12 is 2 away out of 3. Negative 4 2/3 is like negative 4 66/100 approximately, or negative 4.6 repeating. So that is a larger negative, which makes it a smaller value. It's smaller than this, which is negative 4.6. Remember, 0.6 repeating is larger than 0.6 where it terminates. And then negative 4 1/3 is 0.3 repeating, so you're getting larger in value. And then negative 4.07 is the largest value. The smallest negative is the larger value. Bigger negative, again, is smaller in value, if that makes sense. Number 8, a union question. A union and intersection question. Union and intersection. We know how to interpret those. We have a foldable for that. So here's all the info. We have a universal set, and in this universe, we only have negative 5 up to 5. So only anything negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and 5. That's in the entire universe. You can't go outside those numbers. You can't go smaller. You can't go bigger. Now, within this, we have basically one circle, if you think about it, that contains negative 2, 0, 1, 3, and 5. Kind of like that. Then in the other circle, you have negative 2, negative 1, 0, 1, 3, and 5. Now, in a moment, I'm going to make a Venn diagram, but for now, just understand this is sort of separate from this. If we put everything together, that's the union of them both. So when we say, for question number 8 here, what is the union, which is this question right here? What's the union of A, B? A union B, not ob, but A union B is going to be combining A and B together. So all together, what do we have? You put them both circles together. And you'd have negative 2, Well, negative 2 is in both of them, so you can just count negative 2 once. So number 8, negative 2. And I'm going to go ahead and say A union B again. I'll put equals, and I'm going to put my little brace here. It's called a brace. And negative 2 is in both. But actually, it doesn't have to be in both, but it just happens to be. So negative 2 is in both. And we also have, let's try and get the next number on the number line. Negative 1. Now, it doesn't have to be in both. Union means putting them all together, so they don't have to be in both. That's something else. Let's keep going. We see 0. I'm going to cross off 0. 1. Cross off 1. Everything in both. Not everything in the universe, so don't confuse that. A union B, just A and B together. We're not talking about the entire universe. What else do we have? We have 3 over here. Put 3. And we also have 5. We got 3 and 5. And that's the answer for the first part of A, for half credit here. Now the other part is A intersection of B, or A intersect B. So it's like saying, where do they share the same number? So what numbers do they share? And let's call that circle A right there, and we'll call this circle B right here. So we know circle A is here, and B is here. And we're looking for the black region. So they share negative 2. I'm not going to be able to fit this all in there, but they share negative 2. They share 0. Should be right in this region here. They share 1. They share 3. And they share 5. So the only thing they don't share is what's in B, this guy right here, which is negative 1. So I just put this in B alone. This part here is only in B. Everything else is shared by both of them. So actually A shares everything. So intersect is what do they share? And your answer is this. Negative 2, 0, 1, 3, and 5. There. For the next group, numbers 9 through 12, it's your properties, which we have studied extensively. Had 2 quizzes on it, or it was part of 2 quizzes. You made flashcards, you taped them to your walls in your bathroom. You've been studying very hard to get the properties down. So refer back to the properties assignment I gave you that listed all the properties and explained everything in detail. And that's your best way to study properties. I'm going to go and give the answers for these. Number 10 is the associative. Number 9. I'm getting a little bit off here, but number 9 is the associative property of multiplication. It's the same order, x, 0.5, and 8. X, 0.5, and 8. It's just where they associate the parentheses in a different position. The answer would be the same, it's just parentheses change. They've been associated somewhere different. So associative property multiplication, and that's different than the associative property of addition. Addition would involve addition. Number 10 here is the commutative property of addition. I'll just put add. Because what has happened is x and negative y and x. You just flip-flop the x's and the y's. You've commuted them to different places. So that's the commutative property of addition. X plus 1 is equal to 1 plus x. It's just written differently, different order. Commute. Number 11 is definitely the distributive property. It is something that we have become quite familiar with in this class thus far. 2 times 5z is 10z, and then 2 times negative 9 is negative 18, or minus 18, as you can see right there. And the last one, number 12, is called the additive inverse, or otherwise known as the inverse property of addition. Either is fine. You take what you have, 3a, and you add its opposite. You get 0. It's called the additive inverse. Students confuse that with the additive identity. The additive identity is different. It's when you take a number like 3 and you add 0, you get yourself. It's called the additive identity. It is different than the inverse, where you add your opposite to get 0. Okay, so I'm nearly out of time for this particular video. I got to stop this one, and I will begin a new one in a moment.